and squiggly lines and wires and meters and all that sort of stuff. So my parents were devastated because I was going to be a doctor or a lawyer, but not anymore.
Hello, welcome to Not an Audiophile, the podcast. Today is episode 6 of season 1, and our guest is the wonderful Serhan Swift. Of course, partner of Serhan Swift loudspeaker manufacturing, but also a lifelong electronics engineer, and he's got some interesting stories to tell. Morris, are you there?
I think so.
Yeah, okay, you are. And all parts.
I don't know if I'm all there, but I'm there.
Well, the audio's pretty good, so we got that right. And so, look, appreciate your time. It's great to speak to you. You have a wealth of knowledge about all things audio and audio engineering or electronically engineering related. And I never know whether to say electrical engineer or electronics engineer. Is there a difference?
I think the title is still electrical engineer, as in BE,
yep.
But it comes down to your specialty, because a BE can be a power engineer or a computer engineer or whatever. And I mean, I never studied audio at uni, even though audio was a passion from when I was, like 6.
Yeah, okay.
But
so
somehow professionally and at uni, no, I never really did audio. I did a undergrad thesis on developing a music synthesizer, but not audio per se. Our uni didn't have people like, Neville Teal and those sorts of people running courses.
Okay.
We're at New South. I was at New South Uni, the better uni, but we didn't do much in audio at the time. Although I was in my final year, I was working in the communications division.
Okay.
And we had people there who were doing research into audio, audibility of phase. There was one guy doing amplifiers, but no, I was never really professionally. I kind of skirted around the edges, but it was always a passion and always a hobby. And in my spare time, I did a bit of speaker and amplifier building, but not professionally until, sort of got to a stage where, well, it's a passion. Why not? Why not do something a little more active?
Try to spin a hobby into a business, perhaps, which is
kind of, sort of.
Hey, so you say you had an interest in audio from the age of 6. How did that come about? Or what makes you say that? Did you have you had a childhood experience?
Yeah. I think what happened was we moved into a new house that my father had built from scratch, and custom furniture, as was the fashion in those days, and a built-in so-called radiogram.
The radiogram.
And it was stereo.
Okay.
And I remember, one of the first stereo albums, which had a big warning on the front: will not cause damage to mono equipment. So that gives you an idea of how far back we were.
Yes.
But I was fascinated by all this stuff and watching the system get built up by an engineer at the time, and he had an oscilloscope. And once I saw all these squiggly waveforms on the oscilloscope, that was it. I'm an electrical engineer.
So in fact,
I'm in.
Okay, so it didn't just the whole radiogram custom building exercise didn't just create an interest in music or audio reproduction. It was the trigger to get into electronics, full stop, as a career.
Yeah, I think so. Yeah.
Yeah, it's interesting, hey. I can point to how I got a start in it. And it's a very similar thing, not quite as young. We did have a horrible radiogram, but not custom made. But so this radiogram, so we're talking late 50s, mid 60s, early 60s?
1960 or 61.
Yeah, okay, yeah. So
1960 or 61.
So tubes, obviously. So he, this gentleman who created this system, needed an oscilloscope at the house because what do you think was happening?
I think he was repairing something as well, repairing a TV and squiggly lines and wires and meters and all that sort of stuff. So my parents were devastated because I was going to be a doctor or a lawyer, but not anymore.
Yeah, you decided to choose a much more difficult profession. So
that's right.
So I guess we could fast forward to university, although we've kind of visited there. But so you were doing engineering, specialising in. Well, was there a special? I mean, you probably don't specialise in first year, I guess, but
no, but towards the end, you have a number of electives.
Yeah, okay.
So I always loved circuit design.
Ah, yes, yep.
Not so much. I hated computers, hated them with a passion because those were the days of mainframes. You didn't have, or maybe minis. Certainly, personal computing was not a thing.
No.
And so you did batch jobs where you had to fill in these little cards, colour in the squares, and they would be scanned and, boring programs all written in Fortran and, to do simple accounting jobs. And no, that was not for me. And then you'd sort of come back and you had an error because you coloured in the wrong dot and then you'd have to start all over again. It was a pain in the arse and I didn't see the point of it. So then we get to thesis time.
Yes.
Okay, year 4 you had to do a project of some sort of thesis, a major work. And I looked at all the topics and I thought, no, that doesn't interest me. But I had an idea for a polyphonic synthesizer when synthesizers in the early days of Moog or Moog were single note. And I had an idea of how you could maybe do a multi-note one. And then I picked up a paper from Stanford, and they had a polyphonic synthesizer, one of the first.
Yeah.
And they had a full-on synthesizer based on an integrated circuit, one per note.
Right.
So literally a rack of gear and 64-note keyboard, 64 synthesizers. And I thought to myself, probably based on...
There's got to be a better way.
I thought, well, last time I looked, I didn't have 64 fingers. So do I really need 64 synthesizers? I think that was partly triggered by some work I was doing in the holidays for the Overseas Telecommunications Commission, where we did a lot of work on time division multiplexing and resource sharing and, trying to get more into a communications channel. Might have been partly triggered by that, but I thought if we had 10 synthesizers, but we sort of allowed them to be reallocated where they were needed, we wouldn't need all this hardware.
Indeed.
But how to do it?
Yes.
So I designed some hardware, and it actually... after spending a lot of time on it, it actually got simpler.
Okay.
And I came up with a system. I mean, it still had lots of chips in it, but the operating principle was quite straightforward. And so I said to the guy who was going to be my supervisor, I said, well, I don't really like your topics. I'd like to choose my own. And he sort of, you what? You what? You want to choose your own topic? He said, well, what topic would you choose? I said, I want to build a polyphonic synthesizer.
Okay.
And he looked at me like I was from another planet. He said, that's a PhD. I said, no, I don't think it is. I actually think it's pretty simple. and he said, well, show me a schematic and we'll talk about it.
Okay.
And I showed him the schematic and he looked at me and looked at the schematic. He said, this will work.
Okay. Wow.
He said, now bear in mind, I hate computers, right?
Yes.
So he said, okay. He said, I tell you what, the university has just been given by Motorola some of the very first microprocessor chips in existence.
Okay.
And these things were like $400 each when you could buy a Holden Commodore sedan for under $4,000. So these were not cheap.
No, they weren't.
He said, I tell you what, I'll let you do your polyphonic synthesizer based on a computer.
Okay.
So this was like oh, come on, you're just screwing with me now, aren't you? And then he saw my reaction, oh, God, with a computer, are you out of your mind? He said, but to make it interesting, he said, I'll give you an exemption from all your computer subjects.
Oh,
well,
okay.
Where do I sign? Come on. But, to give you an idea, Andrew, this was a computer chip. We were loading these things in binary, opcodes, assembler.
Yes.
There was none of the things where you could sit down and write a program in a high-level language and then have it compiled.
No.
So this was real grassroots computing. But I suddenly realized, hey, this is kind of cool because I don't have to pull out a soldering iron every time I want to make a change. I just have to load a different set of opcodes.
Indeed.
And I started to sort of think, this sort of computing I like, real-time systems, signal processing, doing that sort of stuff, not writing in Fortran with punch cards and God knows what else. This is kind of cool,
Yep.
and that gave me an affection for, embedded computing and real-time computing, and that continued on for many, many years, and that became something that I did a lot of consulting work in and designed a lot of products around embedded systems. But that was where it started. And, so that was, not really an audio project, but that was a direction that I went in.
Well, it's a pro audio product, I suppose. So you, so how did the project go? Did you end up with a successfully running machine, or?
Absolutely.
Okay.
Absolutely. So I did. I only wish I had patented it at the time, but hey, I was just an undergrad. What did I know?
Well, yeah. Just to clarify what time it was in the scheme of things. Now, obviously, the Fairlight is a different type of product.
Interestingly,
Yeah.
Fairlight was also working with the university, but the university was more involved with the Fairlight originator, who was Tony Furs. He came up with the idea of, using computers to do signal processing, and he did the original Fairlight architecture.
Okay.
But then Peter, Peter's brilliant, and Kim, who's also a very good out-of-the-box thinker, they came out with the idea of sampling.
Yes.
And
that was my point. It's a different product in that sense, that it samples.
Well, the main thing what I was really working on the keyboard side of it, developing a keyboard that could generate the signals. And unlike Moog, which did everything using voltages, I was doing it digitally as well.
Okay.
So it was sort of contemporaneous. But I knew nothing about Fairlight at the time.
Yeah.
Other than the fact that Tony Furs and the department that I was working with, we were collaborating on, how to use computers to compress audio and how to use a simple mathematical seed to, generate musical sounds and so on. But then, Fairlight sort of were running, and they were sort of state of the art and developed the CMI. But that was, I guess, invisible to me at the time. But look, it was just an undergrad thesis and something I wanted to do. But then my first job outside uni had nothing to do with any of that. It was designing integrated circuits at AWA, which is one of the two silicon foundries in Australia, other than Philips. And they were doing all sorts of application specific type ICs. Nothing like what we do today in terms, you could count the transistors, it wasn't like today where you got a billion, and it was all done by hand. You were designing the circuits from scratch. Again, most ICs these days are designed using software. You design the functionality and the software then takes it and does all the hard work. No, in those days, we actually designed the circuits. And even the masks were done by hand. You actually,
Wow.
you drew the masks.
Okay.
And then somebody, they had a thing called a rubylith cutter, which was like a clear celluloid with a red layer on top, and you cut these to make the pattern.
Wow.
A bit like how we used to do early, how hobbyists used to do
Early PCBs.
printed circuit boards. Yeah, a bit like that.
Yeah.
Sort of a tape process.
But on a tiny scale, obviously. You're still fitting
Well,
it into a...
Well, you did it thousands to one, and then you reduced it photographically to make the masks that did the silicon.
Yeah, okay.
But it was a totally manual process. We weren't using computers.
No.
We didn't have access to those sort of computers. They just weren't available.
Well, CAD was... Because to put a year on it, which is where I was... We're talking 1978 or 1980 or something.
Yes, you're talking the late 70s now.
Yep.
And then probably a decade or so later, they got more into CAD design. But again, using minis and mainframes.
Yep.
The idea of personal computers, no. We've gone right off audio, but it's quite interesting because
we'll come back again.
We take for granted the amount of computer power in a phone.
Oh, we absolutely take it for granted, yeah.
And, it's a bit like, my first hard drive was 5 meg. Does anybody know what a meg is anymore? We don't talk in meg anymore.
You must be older than me, because my first hard drive was 20 meg, so...
My first was 5 meg, and it cost $5,000, more than a car. More than a car, okay? So that puts it in perspective. Wow. And I remember also... For example, you would have we built our own computers then. We had a thing called the S100 standard bus. Yes. And we had these big cards. So a memory card, which would measure probably about 10 inches by 5 inches, chock-a-block full of chips, pulled about 5 amps, ran stinking hot,
yep.
And it gave you a grand total of 16K. Enough for an emoji, okay?
Just
enough for an emoji.
For a low-res emoji.
And our engineer came back from the States, and he proudly showed us this 16K card. And everybody in engineering is rolling their eyes and saying, "Tony, you bloody wanker! What the hell are you going to do with 16K?
How would you possibly use it?
You're never going to fill that. You're never going to fill that, because we were writing in assembler, and we could build an accounting system into 16K. We had, and then we graduated to 100 kilobyte floppies, 100 kilobyte floppy disks, and you would run your business on that. You could run a whole business on that. But then we got into Windows and graphical user interfaces, and suddenly we were chewing up kilobytes like there was no tomorrow. But this is where we started, this was when you look at how the computer generation has evolved in the space of our lifetime, in the space of 30, 40 years, it's mind-boggling. And the stuff that we do today, I remember going to a lecture by a guy from Intel, and we had the 80286 processor, and he said, "That's it, folks, that's it. That's as far as we can go. It's the limit of physics. We will never go further than that. That's it." Well, I think we're about 1,000 times faster and smaller already. And I don't know if you might remember this, Andrew.
Sure.
Do you remember memory chips with built-in parity because the alpha particles were knocking out the bits?
No, I do not. No, I do not.
Okay, so the size of the cells got to a point; they were getting smaller and smaller and smaller.
Yeah.
And the natural alpha particles that come from the sun or the atmosphere or wherever were actually knocking out computer bits, and we had to build extra parity in there with error correction to cope with alpha particles. Well, we've gone probably 1,000 times smaller than that, and I look at this stuff and I'm going, does this stuff actually work?
So what are you saying? If you took
It does. You
took your computer out in the sun, it would...
just about anyone. It was recognised that there was an error rate, and it was partly related to stray radiation, and that's how I remember it anyway. Or maybe they had the theory wrong, but I do remember that 8-bit memory cards had a 9th bit.
Yeah.
And that was because the error rate was so high, they had to detect errors in the memory.
All right, okay. Well, yeah.
And now we have, in a thumb drive, now we've got gigabytes where the cell size is absolutely tiny. And it's amazing that it works, because, I remember when we were doing, mean time between failure analysis, and we got to a stage where we said, no, there's too many components. This thing's going to fail every 5 minutes.
Yeah.
Well, again, we've gone way past that. Millions of transistors. Okay, there's redundancy built in, there's clever architectural things going on. But, when I think back to that time and what we're doing now, it's not possible. It's beyond the laws of physics. Well, guess what? We are doing it.
Well,
we are doing it.
I guess the goalposts and the possibilities continually move and become smaller. But it's an interesting thing that we've made such inroads in computing, and yet people are now playing music on records, which probably the same records that you were playing or your parents were playing on that custom radiogram in the what was it, early 60s. 1960.
Well, that's a great point. And, of course, there are some people who will not listen to anything that isn't tube.
Well, yeah, there is that as well. That's right, yeah. Which, I mean, I guess the tubes, there are no, correct me where I'm wrong, I mean, it does happen, but are there any new tube designs, or are all the tube designs basically were set in concrete in the 50s, 60s and 70s or something?
I think the ones that are still coveted are still basically old design stuff. I don't think there's been any major inroads. I mean, there was new Vistas that came out, which are your little tiny tubes that originally came. Things like car radios used them. Yeah. And I think if I'm not mistaken, Musical Fidelity was one example where they had them in a preamp or something.
Yeah. They were almost, but they sort of solder into a board almost from memory.
Yes. They didn't have pins. They were wired in.
Yeah.
So.
Yeah. Okay, so
everything old is new again.
Yeah, except old computers. I mean, you wouldn't even be able to find one. I mean, that's it's a bit like a CRTV. If you wanted to know what one looked like and see one in the flesh, I'm not even sure if there's one in a museum, but I guess there is a few floating around, but they're really all gone underground, which is kind of a shame. Well,
we are forced to upgrade because of the software and the incompatibilities, and it's actually quite frustrating that the rate of progress in computer design, if you used to build a computer around a particular motherboard and a particular processor, and you've got all these peripheral cards built in, and the thing fails, you could never buy another motherboard. You'd have to basically throw the whole thing out and start again.
Yeah, they have.
And that was, and it used to happen surprisingly in a surprisingly short time. The life cycles were incredibly short. And that was quite frustrating. And of course, then, the software doesn't run on those older processors. None of the drivers are compatible. So you're kind of forced to move on, even though there probably was enough computer power to do a lot of things. But you are forced to move with it.
I think everyone feels like Windows is rewritten mostly to use up resources to force you to buy new hardware. But hey, look, I'm going to take a quick break, and we're going to come back and speak about. We're going to skip forward in your long career to audio, and to, I suppose, briefly cover your interest in very high quality audio, and you've been in it a while, and we'll talk a little bit about that. So back very shortly, folks.
Great.
Andrew here from Dellichord Loudspeakers. We're at the show, the Australian HiFi show, that is, in Melbourne at the Pullman Hotel, Albert Park, from the 11th to the 13th of October. In other words, a few days, although that would depend when you're listening. If you're listening sometime early in 2026, you missed it. So, because this is 2024. And so we're in 2204, I think I mentioned that. We're displaying with Alex from Audiofix Distribution, who imports EAR Yoshino tube amplifiers and Exposure Electronics, both from the UK. And we're probably almost certainly releasing a new model. It's an affordable model. We're very pleased with its performance, and we'd love you to come and have a listen to it. 2204, Dellichord, EAR, and Exposure Electronics. See you at the show. And we're back at Not an Audiophile, the podcast. Today we're with Serhan Swift, an electronics engineer and lover of high-quality audio equipment, and, of course, designer of various equipments, but I love to say equipments and gears because people seem to use that expression these days because it obviously drives some people mental. Various equipment and, of course, involved most notably with the Serhan Swift loudspeaker manufacturing concern. And, of course, my question is, how come your name is second?
I wasn't expecting that.
Well, we're going sideways from old computer talk. By the way, that previous segment of people are skipping ahead. I mean, the old computers, the numbers are astounding. Both the price, so ridiculous, and the abilities or the performance so poor compared with modern. And of course, the other thing that we mentioned that you told the story of was your polyphonic synthesizer project, which just happened to almost cross paths with a very famous Australian a synth in the form of the Fairlight, which I think was pretty much the world's first sampling synthesizer, I think, or something like that. Not my area of expertise, so I could be tripping over my terminologies, but
look, it had a whole lot of world firsts. All digital, computer controlled sampling. It had composition in it.
Okay.
It was truly. I mean, we overuse the term, but it was truly a game changer. It was a whole new paradigm. In music synthesis and
yes.
And audio processing. It was quite phenomenal.
No, that is the definition of a game changer because it changed the game. I mean, everything's a game changer these days, but really the game isn't changing. But that was a benchmark. So
absolutely.
So all right.
All right, so why is my name second? Well, I could say because...
did you draw straws or what happened?
No. Well, I could say it's because you remember dessert more than main course, but no, I think, look, it was interesting because we had another name, Brad... it's hard to do this without getting into the whole history, but I guess in a nutshell, there was another name that Brad was working under called Brigadiers.
Yes.
Which he based on the British comedy about the military, and there was a rank called Brigadier, and so that was where that came from, and I hated it.
Yeah, okay.
But it was also a case of, well, we were looking at, how can we develop the brand and getting Brigadiers known, developing the brand. And I said, Brad, you've been doing this for 30 years. Everyone knows Brad Serhan.
Indeed.
Everyone. It's just the way he is. He's very, personable.
Absolutely.
And everybody knows Brad. And he, I think, as you said, has, very prolific designer.
Yes.
And I said, why are you doing this? Why don't you use your own name? Why are you developing a new name? It just didn't make logical sense to me.
Yeah.
He was a bit reticent, didn't like the idea of, putting the name there. And neither did I, for that matter, putting my own name there. I don't necessarily like this everything, surname audio. I didn't like that idea. But I said, look, you're a known brand. Let's just put, let's just call it Serhan and Swift, but I want to make it different. It'll be Serhan plus Swift with a plus sign because I like the graphic and all the rest. Then we suddenly realized that you can't put plus into a browser.
Yeah.
So, and it's going to be very confusing if it's Serhan plus Swift and the browser name will be different. I said, no, let's make it easy. Just Serhan Swift. Yeah, it sounds like a law firm, but, let's just do that. And, what I also realized afterwards, which was all new to me, is that in the audio game, people love to know the people behind the brand.
I think they do, particularly with a small to medium-sized brand that's a bit more personable and a bit more bespokey, I guess, that, you may as well expose the personalities behind it, because it allows you to understand how the sound might be, how the product's made, the care, the attention.
Well, I can tell you now that when people ring for service and they say, "Oh, I'm speaking to one of the principals." Oh, wow! I'm not being put down to just somebody
Wow.
who just answers phones.
I mean, it is exactly the opposite these days, isn't it? That all of the corporates
yeah,
don't have anyone
when
answering a phone. There's no phone. There is no phone.
Talk to our what is it, our chatbot, and look at the FAQs. But what I'm getting to is, look, if you talk to me, it's, well, there's the bloody speaker. You either like it or you don't, But that's not the way this industry works. People get a lot of cachet, a lot of confidence, a lot of, they want to know that the guy that designed it is prepared to stand up and, either take the credit or cop a beating, for the product that they've designed. And so, from that point of view, having the names there I thought was a good thing. And out of respect to Brad, he's got a lot more experience in this area. Brad has done nothing but loudspeaker design for decades, whereas I've been consulting in everything from Department of Defense to communications to medical to you name it. But, as a consultant.
Yes.
But he is the loudspeaker guy, and I can sort of look at something and say, okay, I can talk about manufacturing, and I can maybe do some mathematical analysis and modeling, and how we're going to build this thing. And I'm very much into reliability, consistency, and I know my way around audio stuff, but I would never claim to have what 30 years of experience in tuning loudspeakers gives you. Because, it's a bit like you can know everything there is to know about the human body and physiology and hydrodynamics. Doesn't mean you can jump into the pool and win Olympic gold.
No.
You've got to do it.
Yep.
You've got to do it.
You got to learn it. There's a lot of little tricks to learn, and he's learnt them, I guess.
Well, he has, and he has a great ear. And, people develop a way of tuning speakers. Speakers is something that you tune. You don't talk so much about tuning amplifiers, although we do to some extent. But speakers are the big variable. They make the biggest difference. This is why I say to people, buy the speakers first, because they make the biggest difference. But they're also a spatial device. Back in the 60s, we didn't talk about imaging, did we?
No,
70s, we didn't talk about imaging.
Well,
if we could get the sound tonally correct, and we could get rid of distortion, and we could have clean treble and powerful clean bass, we thought job's done. Then all of a sudden along comes the realization that a lot of the listening experience has to do with space and imaging and soundstage, and where are the performers, and do they sound the right size? Are they too big? Are they too small? That is part of creating that idea of something that sounds realistic. And that's where the craft, that's where the craftsmanship really is. And you can only do so much with modeling. Having that ear and having the experience and knowing how to design a loudspeaker is based on experience. I don't want to call it a black art, because I don't think it is, but I think you have to learn what the numbers mean, and designing speakers in accordance with a straight line, it just doesn't work. You've got to know what the thing's going to sound like. And Brad is one of these rare guys who can listen to something and say, okay, I know what's wrong, and I know where to look, and I know what to do to fix it. And not many people can do that.
No. In fact, I was going to say it's a skill. It's not it's the black art bit. Well, the black art is interpreting both numbers into what you feel that might sound like, and vice versa, I guess. As far as getting to the finish line and producing a product that's exceptionally good. And then there's all these other aspects to it. I mean, if we started talking loudspeaker design specifically, we would be here for weeks. So we probably won't.
Yeah.
But there's just, I don't think people for a second realise, just how many angles you can come at with all aspects of the design. Which actually brings me to one of my pet subjects. Not that we were necessarily preempted that we would discuss this today, but we both know the other part of the speaker equation, which is, where is the time, where is the money really contained in any loudspeaker design? And there is a perception amongst some that, those drive units, I've just looked them up on the internet and I can buy them for, $176. So your speaker's not worth, $3,000, $5,000, whatever. It's a gross oversimplification, I think. Have you kind of got any thoughts on that? And I don't probably want to go into the finest of details, but there are so many other things to get a speaker happening.
I couldn't agree more. I think good drivers are expensive, but there's two sides to it. Just because you have good drivers doesn't mean you've got a good speaker. But I often say I wish the crossover was on the outside. And people would realise how much cost and expense goes into crossovers.
Yeah.
Why do I love active speakers? I'm a big active speaker fan because I can build 3 amplifiers and an electronic crossover for about the same price as it costs us to build our simple passive crossover.
Yeah.
In an active system, a capacitor that costs 10 cents, when you translate the job into a passive speaker running at much higher current, much higher voltage, and much lower impedance, that capacitor is now $5.
Yes.
And if you want audiophile grade, and yes, they do make a difference, it's now $50. In fact, I've been looking at a capacitor recently. It's $500.
Oh, wow. Okay.
And, things like terminals. I remember sitting with Colin Watnow, and he was showing me these speaker terminals and saying how good they were. And, this was early on, and I sort of bit my tongue, thought, oh, come on. The typical electrical engineers thing, and this goes to cables, connectors. It's only 20 kilohertz, mate. Come on. How much difference can it make?
Yeah.
But our terminals cost us a bomb, and it's not that we haven't tried other stuff. We don't like the way it sounds. And yes, it does make a difference. And then the cabinet engineering, multi-layer cabinets, bracing, the way you do the cabinet structure. And it's not just a matter of making it dead, because if that's what it was, we'd just make the cabinet out of granite. But you've got to absorb and manage the energy too.
Yeah.
If a tweeter has a diameter of 1 inch, and it's moving a certain amount of air, well, the cabinet has a surface area of hundreds of inches. So if the cabinet's vibrating even in microns, it is colouring the tweeter. And then think about how much energy is in a room. You've got a room that's, 1,000 cubic meters, and you've got 20 people in there, and you're blasting them with audio. Well, the back of the speaker is putting out just as much energy in a box that's 10 cubic, that's 10 litres.
That's right. So,
that energy has to go somewhere. Otherwise, it's going to bounce straight out through the driver. You've got to absorb
that's
it.
absolutely.
And now you get into, and so now we get into, not just bracing, but multi-layered stuff trying to absorb the energy.
Before you move on.
And that's where a lot of engineering goes.
So your analogy is superb. You've got a 1 inch round tweeter, hardly moving. Visually, it doesn't move. It creates tweet sounds. Why doesn't the box create almost the same sound of a tweeter in a way? I mean, obviously, I guess it's resonating at much lower frequencies, but that is such a great analogy because everyone understands that if you put your hand over your tweeter and your speaker, you no longer have the same balance. It sounds dull and dead because you've just blocked out everything above 3,000 or 5,000 hertz or something, or more or less blocked it out. Certainly absorbed it with the back of your hand or the inside of your hand. So that's probably, Morris, one of the best analogies I've heard for cabinet control and the care that you need to design into it. And it's a slightly well, it's a good analogy, but we both know that there's different frequencies probably being handled, but or produced by the box. The box is not producing 10 kilohertz, I guess. We hope it's certainly not. Some boxes probably do. But yeah, how far does a box have to move to create sound? Not far at all, does it? It's
that is the point. It can color the sound. When people do this rap test with the knuckles, I call it audiophile tire kicking, because it doesn't tell you much information at all, other than unless the cabinet is absolute rubbish.
Yes.
And often when people are designing bracing, they think they've gotten rid of vibration, but all they've done is push the frequency up.
Yes.
Where it's actually worse.
Yes.
Than if they had left it alone. And then that's not to say that a cabinet can't vibrate. It just means that you have to tune everything to I guess, somehow utilize the coloration. But if you're after accuracy and low distortion and low noise, and of course speakers are where noise and distortion, the terminology gets quite confusing. But if you want speakers that are really clean, you've got to manage all that energy. And so this is where it's not just sticking them in a box and making it out of anything. This is where the engineering goes. And the better the drivers, the better the engineering has to be. Otherwise, you're just wasting your money.
Absolutely, yeah, and I guess my point was not so much the cost of the drivers, but people drawing. Well, there's one part of the argument which is that they see what they know to be high-end drive units, and then could make, not so much an analogy, but could be led to believe that therefore that speaker must be excellent, or that they could build their own excellent speaker just by buying those drive units. When nothing could be further from the truth, and then vice versa. Would dare to suggest that quite simple drive units can't produce exceptional results. The actual difference in drive unit performance between very good quality and exceptional quality is the finest of differences, really. And it's the difference that matters when you're aiming very high and the rest of your engineering is at a high level and you've got it right. But if you've made mistakes elsewhere, perhaps the benefits of those drive units to some degree, or those more expensive drive units, the benefit is lost. Andrew here from Dellichord Loudspeakers. We're at the show, the Australian HiFi show, that is, in Melbourne at the Pullman Hotel, Albert Park, from the 11th to the 13th of October. In other words, a few days, although that would depend when you're listening. If you're listening sometime early in 2026, you missed it. So, because this is 2024. And so we're in 2204, I think I mentioned that. We're displaying with Alex from Audiofix Distribution, who imports EAR Yoshino tube amplifiers and Exposure Electronics, both from the UK. And we're probably almost certainly releasing a new model. It's an affordable model. We're very pleased with its performance, and we'd love you to come and have a listen to it. 2204, Dellichord, EAR, and Exposure Electronics. See you at the show. And we're back for segment 3 of the Not an Audiophile podcast. We did come to a very abrupt end in the previous one, as the batteries managed to run out. Modern technology and all that, or the opposite of modern technology. We were talking about loudspeaker component cost, or the real costs of designing and manufacturing any loudspeaker. And I think the point I was going to make before I was so rudely interrupted by my batteries was that there are many other hidden costs, and to suggest that speaker A, B or C should cost a certain amount based on the perceived value of the drive units, or the actual value of the drive units, if you know which ones they are, is kind of wrong, and it probably leads you to, it indicates perhaps how high-end a product it is, but the implementation of those parts is what matters. And as Morris, our guest today, Serhan Swift, was saying, the crossover, the cabinet, these are terminal posts are all important things. Let's finish that conversation, I suppose, since we were interrupted. Do you have any closing remarks on that, Morris? And I mean, you're at the sort of mechanical engineering end of the speaker thing for Serhan and Swift. You make it all fit together, at least that's my understanding, and then organise the manufacture of all of the bits. What have you found to be the most distracting, time-consuming and annoying thing to be organising in an Australian-made loudspeaker?
Oh gosh. Well, as you know, we do our cabinets here now.
Mm-hmm.
I've always wanted to support the Australian industry,
Mm-hmm.
but getting people who want to build speaker cabinets is difficult. We outsource our manufacturing, and so most of our suppliers don't just do speaker cabinets.
No.
So, for example, we have a high-end joinery company doing our cabinets. And, if somebody walks in and says, hey, I need to do, a high-end kitchen worth $100,000, well, guess what? Our cabinets are going to be put on hold for a few days. It's just the way it is. There's nobody doing it specifically. But at the same time...
There kind of is.
Well, aside from yourself, but then again, you do other products as well.
I'm busy with all sorts of things, but yeah, there is actually. I mean, probably
the
biggest cabinet maker in the country for loudspeakers would be Cricks in South Australia, but they do not subcontract. That's right, they don't make anything. They do their own, else. No, which is a shame.
So that gives us a choice. Do we? I mean, the CNC part's easy. You can buy a CNC for not a lot of money. But then, maybe 20 grand. But then you've got to get the pieces, you've got to put them together, and you've got to have skill. You can't do this stuff without skill. And painting in particular, spraying a speaker box is not like spraying a panel. And a lot of the painters, love, when they do a kitchen, they're painting panels. Doing a three-dimensional object with cutouts, having to spray from underneath, for example, or rotate the object as you paint it. I mean, look who I'm telling. The way the paint flows around corners and edges. And then in our case, we flush mount our drivers, so we need absolute precision in the cutouts.
Yes.
So you've got to then control how the paint flows around the cutout. And which is one reason why, in some ways, timber finishing is perhaps a little bit easier, maybe, but then you need, skill in finishing it well, and we're just finding that a lot of those skills are disappearing, or people just are not as interested in doing things to the standard that we want. And I'm convinced that dust has a consciousness, because dust can think. Because when you get a speck of dust on your enclosure, it will always work out how to go on the front panel where it's the most visible. It will never go underneath. That just does not happen.
No.
So I'm convinced these things have a consciousness. So, being a bit facetious, but it's not an easy process. We have to often respray cabinets to get the finish that we want. I'm not saying that we couldn't invest $1 million and get it all done by robots and all the rest of it the way the big boys do. But as a small-scale producer, those things are just not available to us. But at the same time, we're extremely fussy about the stuff that we do. That's part of the difficulty, getting people who understand that and are willing to do it when they can be making a lot more money doing other stuff that's easier to do.
Well, perhaps there's a big difference between manufacturing things in Australia and perhaps, say, in Europe, as an example, where you have specialist cabinet makers that just do loudspeakers, that you can basically send them a drawing and get a price and have a conversation about how it's going to be made, and they'll give you some kind of indication of cost. This is not something that we have available to us in this country, other than really only just ourselves. And sure, we do it in a tiny way, and we're not going to be doing it in a bigger way, because I can't get the people that I need to help me do it. So there's only so many hours in a day, and that's the problem, because I imagined when I started Stereotech that I would employ one or two talented young people with lots of enthusiasm and excitement for doing quality cabinet making and painting, and this is not worked out. So the lack of interest in getting one's hands dirty is not to be discounted. It's a problem, and it's something that I think the whole world is going through. It's just a change. There's so many career opportunities where you don't get your hands dirty and you don't breathe in the occasional bit of chemical when the mask is not working or something. But, it's...
you just write an app. Write an app and sell it for $1 million, But the other point that I want to make, and I'm sure you know all about this, is when you get into more exotic materials, for example, like birch ply, not everything's made out of chipboard and MDF. Try and get consistent grade birch ply throughout the year. Every shipment is slightly different because it is a natural material. It's grown, and particularly since COVID, getting reliable supplies and getting consistent quality is really, really difficult. And yes, what you make the cabinet out of, it matters. It matters a lot. That's another headache is, consistency of the materials that you're using and, how you deal with that in manufacture and in design. And, little things matter. For example, our crossovers are fully hand wired. And I was surprised at the difference it made sonically. In fact, we changed the way I looked at the crossover, and I made a few changes, partly for efficiency, but partly because I thought it would be electrically better. And we didn't tell anyone. And we just incorporated that change, and then the phone started ringing. What have you done? And I thought, oh no, we're in trouble. And it was no. These are right? Way better. We can hear the improvement without telling anyone anything. So it actually worked out. It worked out well.
Yeah, it could have gone the other way.
So
of course,
it could have gone the other way, but But then you also go down this rabbit hole where how much detail engineering do you put into a speaker? It'd be nice if it all went together like Lego, and if none of these things really mattered, and if you could get, some kid who had just learnt what end of a soldering iron is the one you hold to do your soldering. It's just not that easy. There's a lot of skill, and feeling that goes into assembling a quality loudspeaker. And yet, I spoke to one company in the States at one of the trade shows, and I said, gee, that's a pretty impressive speaker for the money. I said, how many of these do you make? And he said, 20,000 at a time.
Wow. Yeah, okay. And this, you've just reminded me of my point where before we had the battery incident. That exactly was where I was headed, is that small manufacturers are up against it as far as simply the amount of pieces they're going to make. And if you divide your R&D into 100,000 pairs versus 100 pairs, you can spend a year developing a model, and it really only costs, it's an hour's worth of time per pair of speakers, if that. Whereas small manufacturers, obviously the R&D, because the same amount of time is spent developing the product, it's not like you can spend less time. In fact, you probably spend more time because you spend it slightly less efficiently than a larger manufacturer's bigger laboratory, etc. So they might have.
Well, I'm going to contradict you on that.
Oh, okay.
You see, the big guys have economy of scale.
Yes.
But they also have momentum.
Yes.
They cannot change things on the fly. And in fact, I did a project some years back, nothing to do with audio, but we had taken a product from concept to reality in 6 months, and we had a component supplier say it would have taken us 5 years.
Oh, wow. Okay.
Simply because of the momentum, the red tape, the cost of setting up, the way they did things. So to some extent, we have a flexibility. No, we don't have their economy of scale, but at the same time, we also don't have their overheads. I mean, if their business just hiccups, they're out the door backwards. I mean, what do you think happened to compact computers? They didn't predict things correctly. What do you think happened to some of the big semiconductor manufacturers? They didn't predict things adequately. In some cases, they said, there's going to be a downturn. They got rid of their skilled staff. then all of a sudden there's an upturn and they can't catch up. They don't have the staff anymore. So we have that flexibility, and also we can do things in manufacture that they cannot afford to do. They're more highly automated. There are processes that they just cannot afford to do. Every set of speakers that we do, and I'm sure same with you, is every pair is individually tested, individually measured, and listened to before it goes out the door. And now, if you've got customers that understand that and are prepared to pay for it, look, I often compare it to Aston Martin. Aston Martin still hand beat their panels.
Do they?
Everything is done by hand. Well, that was the last documentary I saw, which was a while ago, showed them hand beating their panels. Maybe
in the late 70s.
Yeah, but a lot of stuff is still done by hand. You know, the leathers are selected by hand.
Oh, absolutely. I think,
stitching.
A lot. I mean, the vast majority
there are going to be customers who are prepared to pay for it. The only difference is with audio, much of it you can hear. I mean, every component that comes in, we remeasure and calibrate every component and hand match all the components that go into every pair of crossovers. Now, the big boys are not going to be doing that.
No, I want to make a point about the big boys is that, and this is where the end user, the person buying the speakers and enjoying the music through them, may not realise the big difference between a large manufacturer making 20,000 pairs and you or I making a 6 or 12 pair batch or whatever is that consistency, that quality, not just quality control, but the fact that every inductor is trimmed and is the exact value of the next one, etc., and also the complexity of how the product fits together. We are less concerned about how difficult or easy it is to put together. If the result, the sound quality is worth it, we'll take the harder path, whereas a large manufacturer, I'm sorry, but everything is just literally thrown together, and very much thrown together it has to be, because they're using semi-skilled staff to screw everything together, and it has to be done in such a way that person who's not an electronics guy can fit it together adequately well, and so everything's sort of slung together with connectors and hot glue and a few staples, and that's your product, and that's not how bespoke. Well, I call it bespoke's not the right word, but small volume manufacturers are potentially doing a much nicer job of actually, putting the product together, and some are, some aren't, but I mean most. Absolutely, that's why they do it. They want to make a first-class product. And I think, the old days of buying a pair of speakers and it lasting 30 or 40 years is most likely to happen now with a small manufacturer, where the quality of the product, the components used, is very high, and the care with which it's screwed together is very high. And as someone who, for a living, has to pull other people's manufacturing apart and try to make it work again, this is something we're seeing less and less of. There was a time back in the day when it was everything, well, it wasn't fancy, but it used good materials, and it was screwed together in such a way you could get it apart again, and this is less the case now. And of course, in the bottom end of the market, forget it, you just drop it in the wheelie bin. I mean, if you think that you're repairing a JBL, yes, I'll use a brand, or some other Harman $369 product, just drop it straight in the bin. I couldn't even tell you how to take it apart. It will clip together in a way that no one would understand except the person who designed the plastic clips.
I often say we don't want to see our product, in the council cleanup.
No,
we consider our product an investment. But the important thing is that we don't just do this for the hell of it. Most of these things, to some degree, are audible. If you put these in a high-end system with good electronics and everything fine-tuned, you will hear. It's extraordinary, the things that you do hear. It never ceases to surprise me how just little things, how you mount the drivers, how you put things together, and all the things that we've been alluding to, they're audible.
Yeah.
That's the whole crux of it. We're not just doing it
It's
so
annoying.
we can say, "Oh, it's better made,"
So
but
annoying.
it is audible. And if you start to slip up,
Yeah, that's right. That's why it's annoying.
you're going to know.
Yeah.
You're going to know.
So we'll stop the unpaid ad at that point, which it isn't, but it's we are harping on about our own efforts a little bit. I'm interested to know. So you got that interest in audio at a very young age, and then you sort of worked in all kinds of industry related to electronics, but then you've come back to audio, later in life, I guess. But have you? I mean, what's your audio highlight other than being part of? Here we go again, another ad, Serhan Swift team. Other than that, what's some of your highlights in the audio side of things? Things that have you look back and go, wow. And I could be talking about something you've heard. I could be talking about some product that you've owned, or what have you.
Look, I think getting excited about some of the technology. I mean, if somebody had said, years ago that you could have a gadget like an iPod Nano, the size of a credit card, not just storing thousands of tunes, but doing it with quite outstanding fidelity, that impresses me. I'm impressed with what you can do with silicon, and I've got a saying which is silicon is cheaper than copper. And this alludes to things like what you can do with digital processing, what you can do with the dreaded Class D amplifiers, which I'm a huge fan of, the technology in terms of, what you can do with it. 200 kilogram amplifiers just don't impress me, but 1,000 watts that you can lift up in the palm of your hand, that impresses me. I'm about elegant engineering, stuff that people have sat down and really had to think about to make it work. But once they do make it work, once you make some of this stuff work, it's like Arnott's, baking biscuits, it's all pick and place robots, surface mount.
Yep.
You can make it so cheaply. And what I love about that is now high quality audio is accessible to just about anyone. And I love the idea of accessible audio. I get more excited at the idea of putting together a system for under 10 grand that blows people's socks off than I will ever get excited about a megabuck system, which don't really excite me much at all.
Well, they can be exciting, but either way, you're not
exciting,
buying it.
But who's going to buy it?
The
sad thing is, I think a lot of people buying that stuff are collectors.
Yeah, okay.
They're not people who want to listen to music. What I love is, when we have a difficult customer, as we had a while back, the husband wanted the speakers, the wife clearly didn't.
Yeah.
But when she heard them, when we went to their place and did a demo, the wife just said, "Oh my God, I've never heard it like that before."
Is that right? Yeah, that's good stuff.
And, and when that happens, I thought, this is why we do it. Because it isn't for the money. I could make more money flipping apartments, much more money. But we do it because, there's a certain passion and an art. And at the same time, what I love about audio is the number of times you go, well, shit, that wasn't supposed to happen. And aside from smoke pouring out of an amplifier, which not so good, but the fact that you're always learning and you're always finding out, I don't know quite as much as I thought I did.
Oh, wow.
And that for me, that's the excitement, because if I thought I knew everything, then I'd take up basket weaving or something else. I'd be bored. And
there's something to learn every day, isn't there?
That constant journey of discovery, and the fact that, look, at the end of the day, I'm not going to use the old cliche, it's all about the music, because it's not. But
okay.
We enjoy music.
We
love the fruits of our labours. Every time I put up a pair of Mewtwo's to the listening test, I think, they're pretty bloody good. They really are.
Well, you've sort of created a small a small offspring, really, haven't you? I mean, that's I guess that's why manufacturers are in manufacturing to a fair degree. Is you're making something, it's a tangible thing. You can hand it to someone, they can plug it in and get it to make music. And I mean, there's you talked about writing an app earlier, and that's what a lot of people are doing. Not so much apps, but whether it be software, anything software related. Ultimately, it's kind of cool for a second when it does what it does, and it does it well, and does it hopefully without crashing. But then it's kind of nothing, isn't it? It's just vapor, and that's electrons zinging around or whatever. And it's tangible products, and making them is a very rewarding thing. And I guess it's something that a lot of people are going back to. I mean, there's plenty of 20, 30 and 40-year-olds who brewing beer or something, or making cheese, or making furniture.
I tell you what we've omitted, and that was that the Mewtwo almost didn't happen, because when I approached Brad, it was, I've built these. I already had some active speakers I had built back in 2005, and everybody who heard them said, you've got to capitalize on those. They sound fantastic.
Okay.
They were also huge. They were huge. They were like 1.5 meters tall, a meter wide. They were big things.
Yep.
But then, I won't go through the whole history, but the Mewtwo was done as a stopgap because, we needed some cash flow and our active speaker wasn't quite ready. And then we learned at the time, audiophiles and even people into high-quality audio were not buying active speakers. Yeah. And the Mewtwo, everybody that heard it loved it. So it was kind of, this speaker almost didn't happen, because we didn't actually set out to build a passive loudspeaker, or at least I didn't when I said, Brad, I want you to help me build a speaker. So it's quite funny how the Mewtwo did evolve. And, it was the customers that ultimately created the pull, because our original intention was to go active DSP and all the rest of it. So it was going to be a stopgap, but it kind of took over.
Yeah, it's an interesting thing that the active DSP is such a great solution, and of course is almost universal now in pro audio, but it hasn't at all made a place for itself in HiFi audiophile home listening circles. It's lots of people have got it, and those people love it, but I would say that is less than 5% of customers. I mean, clearly you go to a giant audio show and it's 95%, if not more, passive loudspeakers. Maybe that's not quite right. When I think of some brands, you think of them as passive, but perhaps they're actively driven, but by giant Class A/B amplifiers. But
what's interesting, I don't interrupt you, but what's interesting is it's taken off at the low end.
Yeah.
So you've got your $1,000 active speakers, but as soon as you go up in price and performance, aside from exceptions like maybe Meridian, the industry just has not adopted active and DSP.
No.
It still is. The vast majority is still passive loudspeakers, and I think that's interesting in itself, given how other areas of technology have moved, and also, as you pointed out, how the professional people have gone.
Yeah.
So
it's not everyone in pro, I don't think, but it's certainly the majority of pro audio in all areas, whether it be studio monitoring or obviously in big venue systems, absolutely active. Yeah. But I guess they've just gone, this is the best way to do it. Whereas I guess that's home hi-fi. It's hardly surprising it hasn't taken off in a way, because we're still playing records and using tubes, as we both mentioned earlier. So it's perhaps not surprising. But look, it does. Of course, I believe this is the reason. There's the key reason is that you can't then experiment with different amplification, and that's an integral part of the hobby, if you like.
I think if audiophiles were building a car, they were buying a car, they'd probably buy the engine from one company, the brakes from someone else,
yes,
the suspension from someone else, and probably end up killing themselves. But that's another story.
Well, yeah, there would be some interesting cars driving around, that's for sure.
There certainly would.
The Homer comes to mind, if you remember that.
But what you've also touched on, and I think it's very important, is there's no absolute. Different people like different things, and you know what? That's okay. And if you are a tweaker and you are into the equipment more than the music, that's okay too. It's just a different aspect of the hobby. It's like the people who buy a Ferrari, but they never drive it. It's in a museum. They just want to look at it. And then there are the people who want to buy it and pull it to pieces, from the get-go and think they can make it better. And then there are the people who drive it and don't care if it gets scratched or dinged because they love the driving. So they're all Ferraris, but they're different aspects of that particular thing. And I think the same thing happens in audio. If some people are into just the sound more than the music, well, that's okay. Who am I to judge? That's fine. It's just not my aspect of the hobby. Ultimately, I want to listen to music and I want the music to sound beautiful and to, create an experience rather than an experiment. When we work developing our products, we are doing an experiment. When you listen to music, it's an experience. Yeah, and I think that's what's unique about this. Those two aspects of what we do, the measuring and all the precision and all the engineering, and at the end of the day, you just sit back and you enjoy it, and that's what makes this so special.
Agreed, absolutely. And look, I think on that note, we might wrap up, but unless you've got some particular point you want to cover, because obviously we're going to have you back on the show because there's a whole bunch of things that you and I have spoken about on previous occasions that we feel strongly about, and yet we've managed to not mention any of those things today. So I don't know quite how that happened. The inability to stick to a script would probably be the main reason, on my part at least. So, there were things that we mentioned in a brief phone call earlier today. We were talking about noise of all kinds in an audio system, and I think that's a subject in itself, and how some of the noises that we're referring, the types of noise, are things that people probably don't realise exist. In fact, perhaps the least important one is the one that they spend the most time concerning themselves with, which is, electrical noise in the mains power, when there are many other noises, in my opinion, that are more important. So, look, keep going, Morris?
Go. No, I was going to say that, noise is just one word, but it is such a complex subject, and it's not just the noise itself, it's our perception of it and how we process it, and it's often key to how we perceive something. It's a huge topic. It is,
and that's where I'd like to go next. So,
okay,
I'd like to cover that in some detail because you've got a great grasp of how it works, and I've got things I want to complain about. So I thank you again, Morris, for joining us today. It's been
my pleasure.
Greatly appreciated, very interesting. And I would like the audience, if you've enjoyed the last 4.5 hours or however long it went, if you'd like it to, anyhow, I think it was actually quite short. As not an audiophile podcast go, this is a shorter one, but only just. We'd like you to follow and like and subscribe and all of that stuff on the various platforms that the podcast is available on, whichever one you're using. That would be much appreciated, so that other people can then find us. And so thanks again, Morris. I would say we'll be talking again within the next week or three and discuss the issue of noise, amongst other things.
Terrific.
Thank you again, and we'll see you later, folks. Much appreciated.
Thanks for the opportunity, Andrew. A pleasure.
A pleasure, Morris.